Today, we're going to enable the Staticcheck linter in our Go application. So, what is Staticcheck linter? So we go to the website, and it is basically a linter that checks your Go code for bugs and performance issues. Basically, you would want to run it to find issues in your code before they become an actual bug that perhaps a customer sees. And it includes a bunch of checks, each of which can be disabled or enabled individually. Of course, it enables most of these by default. And so our project is using several linters, but not this one. So we're going to enable this Staticcheck linter in our project today. Now, to run the Staticcheck linter, we're going to use Golang CI. So Golang CI runs a bunch of linters in parallel, right? So it's not just using one linter, it's using a bunch and it runs them all in parallel, which makes it efficiently to run a bunch of linters. It also enables linters by default. And Staticcheck is one of the ones that enables by default, but in our project we've actually have disabled it in the past. So now we're going to try and bring it back. We're using all the rest of the default ones and a few other ones as well. Okay, so let's get started. So we're basically going to use Golang CI lint to run our Staticcheck linter. It is possible to run Staticcheck by itself, and if you go to documentation, it'll tell you, how to run it on its own, but we're actually going to run it via Golang CI. So let's go into our project. We're using JetBrains IDE, Golang IDE, and we have a terminal here integrated into JetBrains, so we're just going to do everything from here. So first we need to make sure we have Golang CI lint installed. Now if we go back to the Golang CI documentation, install here, there's a bunch of ways to install it, right? To brew, etc., etc. We're actually going to use this method, and it is not recommended, but what we found is when installing this method, we end up with the same Go minor version as our project. And if the installation of Golang CI lint, if the compile is on a different Go version, then we see type check errors and other issues. So we've actually been using this method, right? So I can just run this in my terminal. I actually have it installed. Let's see. Hope I don't break anything. All right. Okay, and then to check the version that we have, we use -- version like this, Golang CI lint -- version. We've got version 161, build with Go 1.23, and if we go to our project, go.mod, we should see the same version here. I think we're just making sure we have the minor version correctly. I don't think the patch version is significant. All right, so we got the Golang CI installed. So now we can run Staticcheck. So if you want to see like the command line flags, we can go Golang CI lint run -- help. That'll show us the command line flags we can use. So in our case, we're gonna run Golang CI lint run disable all. So this is just, we're disabling like the default linters, right? And then we're gonna enable Staticcheck. So we're just gonna enable a single linter, right? Because we want to see what kind of results we get. We want to fix those results before we actually check that into our CI. And this will work for you. In our case, we're going to throw a couple more switches. First of all, we're going to put a timeout here because we have a pretty large project and we want to have a bigger timeout to give the linter a little bit more time to run. And these flags are kind of useful as well. The dash dash max same issues. We're going to disable it. By default, I believe it's 3. We actually want to see all failures. Otherwise, we just see 3 by default. So we fix those 3, and then we have to rerun the linter to see the next 3, etc. So we're going to fix all of them. So we just want to see all of the issues. And a related flag, max issues per linter. Also disable that. There's also a way to exclude some directories. So we can exclude some directories to kind of reduce the noise. For example, we can exclude node modules because this is we have a unified monorepo, so we have front end and back end here, and we actually don't need to parse node modules. Okay, let's run this. Exclude dir, okay. Exclude dirs. There we go. And we're running. And I'll pause this to let this run. Okay, ran, and we have a bunch of fails. Most of them are this SA1019, right? And if we want to see what that is, we just go to the Staticcheck documentation, linters, checks, and then search here for SA1019. There we go. Click on this for more info. There's not that much info, basically using deprecated functions, kind of self-explanatory, but there's a lot of these, right? And are these real issues? Like, that's my first question. Let's see if we can scroll to the top. Okay, to the top. Okay. First of all, IOUtil has been deprecated, right? The first one is a Go issue. It's basically saying use something else. Now, is this going to cause a bug? I don't think so. Go has pretty strict backward compatibility. Yes, it would be nice to fix this, but it's not absolutely necessary. We jump to another issue, like this issue. This looks like a deprecation in our own code. And you see right here, my IDE is already flagging this. So I actually don't need Staticcheck to tell me about this, because my IDE is already telling me that this has been deprecated, right? And this is in our application code, right? And we just have a bunch of these. And the fact is that a lot of these we can't fix right now, because we can only remove some of these deprecated methods when we go to the next major version. So I'm actually not worried about the internal deprecation messages, and I'm not too worried about Go deprecation messages as well. Yes, it would be nice to fix this, but the fact is that we're mixing Go, which I could fix, with internal, which actually I don't necessarily want to, or in some cases I can't fix right now. So this check, in my opinion, is a bad idea to enable it by default, right? And I imagine a lot of people that try Staticcheck and see all this noise from SA1019 are just gonna say, not useful. I'm not gonna use this Staticcheck. Well, and it's quite possible that we have done that ourselves, and that's why we have this check disabled. But what we're gonna do, actually, we're not gonna stop right now. We're gonna, give this Staticcheck another try, and what we're gonna do is just disable SA19. So if we go to the settings, if we go to Staticcheck settings, configuration, and we see that, checks, yes, we see the default values of these checks. So by default, it's disabling, disabling these checks. So what we want to do is we want to disable that SA1019 as well. So we're actually going to go and create a YAML configuration file, which will pass to GoLint's what's our tool? Golang CI lint that will disable SA1019. So here's how we're going to do this. We're going to create a file. We're going to create a file called file new, okay, called Staticcheck YAML. And this is just temporary, right? We do have a configuration for Golang CI already, but just because we're only running Staticcheck right now, we're going to create a separate file just for it. And in Golang CI, we can actually take a quickly look at our main Golang CI file, which has configurations for other things. And this is the part that we care about, linter settings. We're going to do linter settings and Staticcheck, and then it the rest is just the options of Staticcheck itself, right? We can pass these things down here, so we can grab this checks part. It's not letting me grab. Here we go. And it's YAML, so like this, and then we add minus to disable SA1019. All right. Okay, so how do we tell Golang CI to use this? So if we go here, we go -- config and then static check YAML. Okay, and let's run this. Because did I not save this? Oh, it's not in my. Okay, need to move this to top of the tree. Yeah. Move it. Okay. Let's run this again. Are you kidding me? Top of the tree, it's right here. Staticcheck YAML. Okay, I misspelled it. Staticcheck YAML. Okay, it's running. Pause this. Okay, finished running. So we got some new fails. Let's starting. It's not that many. It's reasonable. So let's start looking at them. And it's nice that I'm running this inside the IDE because I can just click on this and go here. Arguments have the wrong order. That is actually a bug, right? The error has to be first. So that's good news. I actually found a real bug that could cause issues, right? This is how it should be, according to the method explanation. So that's cool. This is a test _test. So it's telling us that call to fatal F should not happen in a Go routine. That makes sense. I believe if we want to see extra documentation on this, we could go to the SA2002. We can go to the checks, search for SA2002 here, and maybe we'll get a bit more documentation. Unfortunately not. It'd be nice if there was a bit more docs here. I mean, this makes sense intuitively. I believe the reason is because of the stack trace. If you fail inside the Go routine, your stack trace is not going to be it might not be quite correct. So I believe the way to fix this, like we could ignore it because, it's a test, so it's not a huge deal. But, if this test fails, could be hard to debug. So I believe what we want to do is we want to do tlog f, say message. Yep. Thank you. And then we just do tfail, right? Tfail tries to call the parent. It does not call fail now, unlike fatal f, right? I believe this will fix it. All right, SA 2002, 4001. This can be simplified. Yeah, this makes sense. I'm not sure why the developer added this. We can just delete it. Let's skip around a little bit. 4005, ineffective assignment to current year. So I see a struct current year being assigned. We have a template being fetched here. Then we execute this template. So if we go inside this template, password reset, we see the current year being used here. So this doesn't seem like an obvious issue, right? And like, is this check supposed to catch things inside a template? I feel like if there was an exception for templates, it should be documented. What was that check? SA 4005, SA 4005. It does not mention anything. It does not mention this. So is this actually a problem for templates? We have a test here, a message test template processor. So we can just say tlog print this out just to make sure it's working and run this. And of course, I'm being ironic here, sarcastic. This fails. Assets may not be used when running as a library. Why? Because I'm trying to fetch an asset here. And we could go down this rabbit hole, or we could just hack this code to actually just say template.new blah blah, and then we can just put the code, hard code the code in here from the template. Where is it? Yeah, so as you can see, I'm kind of going down a rabbit hole. All right, I'm not sure if that check is doing the right thing, if it's a real fail or false fail. So I'm just gonna, so current year is here. Instead of doing this, I'm just gonna kind of hard code the template here, and I think this takes the same arguments. Yep. Okay. So let's see if the current year is there. Go back to our test, mail test, and we run it. Okay, and we printed out our message, and the message does include the year, so it looks fine. It seems to be working fine. The SA 4005 said ineffective assignment, but this is a false fail. You know, this is a thing that a lot of people don't like, right? False fails. False fails. I'm spending time to look into this, and then I figure out it's not needed. So it's like, instead of helping me, this is actually slowing me down. Unfortunate side effect of some of these checks. So what we want to do is we just want to waive it. And we can waive it in line by over here we say no lint colon static check. And this is basically how you waive things using Golang CI lint. And then we can say SA 4005 4005 false positive on for templates. Let's just say go templates. Okay, moving on. Do we have another 4005? Ineffective assignment to field B. Okay, so we have a value function which should be not modifying the struct, and in here we are trying to modify a struct. Now it's a little unclear, right, because this is a slice, but the fact is this slice will not be modified by this. So this is potentially a bug. I'm not sure what the person was trying to do here, but currently it does nothing, and it's part of a test, so you know, not super worried about it because it's part of a test, so we'll just delete this. All right, let's go on to other fails. Okay, this value of repo is never used. Yes, we do assign repo here, but then that's it. It was used earlier, was created here, then it was used here for checks, and then down here it's not used. And this is, you know, in this case it's not really a bug, but this could be a potential bug, right? Maybe someone assigned it and wanted to use it, but then they forgot. Right, so this is definitely a good check here, and we're actually failing this a lot. 4006, we're actually failing this a lot. We're not going to go through this in this video, but yeah, this is a common check fail. It almost feels like, you know, if you assign a value and never use it in Go, it doesn't compile, but then if later you assign it and don't use it, it's fine. It's almost like, it almost feels like the compiler should have caught this case as well, right? If it's catching the initial case where initial assignments never used, but it's not catching that the it's almost like, you know, it should be part of the compiler, right? Maybe it's a miss on the Go team's part. Okay, let's move on to the next one, SI 4009. Context is overwritten before first use, so we're passing in a context, but then we're overwriting it down here. Yes, this is actually potentially a bug, and it's hard to tell. This is actually production code here. It feels like the intention is for this context to be down here, but you know, this is definitely potentially a bug. I'm not, you know, it's context. I'm not too worried about it, but yeah, that's danger as well. If I change the code, could I be introducing a new bug here? Right, and cancel is duration. What is going on with timeout? What's it returning? It's returning a cancel func. Okay. We can just make this more explicit. I don't know, maybe this is overkill. Like this, and then we do the assignment. Okay. So should we take a look at another one, 4009? This is in a test. Host is overwritten before first use. It's in a test. I'm not too worried about it, but yeah, we're passing in host, but then we're assigning them to something else. You know, we should just not be passing this guy. Where is it? They're used host test.go and decide this file. Okay, just don't pass this if you're gonna overwrite it. Check host issues with ops. Okay. Wow, you know, this bubbles all the way up. Now we've got this one not used. Interesting. check host issues with opts. Just fixing the obvious issues. Yeah, I mean this is solid check. Let's move on to another check. The resultant of append is never used. So we got this slice here, we're appending to it, and then that's it. We never use this. Yeah. Like perhaps there was code that was using this, or perhaps someone intended to use this. So, you know, it's hard to tell at this point whether this is a bug, but this, you know, this is definitely an issue. At this point, you know, all we can do is just delete it and assume that the testing is sufficient. You know, our QA and testing have caught any potential issues. Let's move on. 5001. We're using file.close before we're actually checking the error. Reasonable check. Let's move on. Possible nil point of dereference here. It's saying this is a pointer. What's a pointer? Want D, is this is a map? Okay, so is it saying this map may be null? This map may be null. This is inside a test. We know we could go down the rabbit trail and figure out exactly what this is doing, or we can just say require, this is going to work, require not nil. Right? And this should effectively check to make sure this is not nil. Oh, tells me some additional information. Okay, let's check this. This check suggests that the pointer can be nil. Why is this? Okay, is it squiggly because I already added this not nil check? If I remove this, okay, we got my ID saying it's not nil. Static check saying it could be nil. So let's just trust our IDE at this point and we get rid of this thing. Okay. 6005 equal fold, right? What is equal fold? Strings equal fold. And if we look at this, it's basically for Unicode, but is this a bug or is this just something nice to have? Let's take a look. SA 6005. SA 6005. Let me do one more thing. Because you see SA6 performance issue. So this is kind of a hint. SA6 performance issues, so 6005, inefficient, too lower, both doing too lower and then doing comparison is more expensive. I agree. Yeah, so this is just a performance thing. Yeah, that's a good catch, good performance catch. And we're going to return if it's equal. Yep. And let's skip down to the next one, no, last one in this case. Let's see what's going on here. Uh, Only the first constant in this group has an explicit type. Okay. Are you sure? Let me check. Here it's just where. Okay, that makes sense. Right, this is typically used with creating a type just to be safe, just to make sure people aren't putting any old string in here. But in this case, we are putting any old string in here. So yeah, this makes sense. So like this is a check. We explicitly use the type here. Now, a related question is, I mean, it feels like the way it's written, that's the intention, implementer's intention. So, and same file, yeah, same file. What about down here? Same thing. Okay. All right. So I didn't fix everything, but I went over the issues that it's catching. We have a big project, several years old, so it caught a reasonable number of issues, and they could be all fixed in a single swoop. So I'm going to do that. So after I fix all the issues, what I will then do is I will add our configs that we created in Staticcheck YAML. All right, I will just add these linter settings to our main Golang CI, to our main config file, which is by default it's .golang CI YAML. So I would go ahead and just add them here. Static check. Is this alphabetic? D, E, G, R, S. Sure, at the bottom. Here we go. I would just add these here. I would do the fixes, and then I would check in the code, let it go through PR review, and then we are running Golang CI lint in our CI, so static check will be enabled. So what are my overall impressions of static check? In general, the issues it's catching are reasonable, and I do see that it's definitely either catching bugs, like that first one that we caught there, that the argument variables were swapped, or it's suggesting that perhaps there was a bug because the implementer perhaps wanted to do something else, or was intending to do something else, and something's not right with that code. So definitely thumbs up. I mean, the only downside is that deprecation check just generating so much noise that I'm afraid some people will just forget about this static check. It's just too noisy. But I think it's good. I think it's a good one to use in your project. And that's it for today.